We have another sample problem for a calorimetry experiment. In this case, we have the hot water and the cold water added together. So it says, calculate the heat given off by the hot water of 50 grams at 40 degrees Celsius when added into 200 grams of cold water at 5 degrees Celsius. Temperature reading in the calorimeter is 9 degrees Celsius. So let's say we have hot water and a cold water. The cold water will be our calorimeter. And we have a 50 grams hot water and 200 grams of cold water. The initial temperature for the hot water is 40 degrees Celsius. And for the cold water, our mass is 200 grams. And the initial temperature is 5 degrees Celsius. So if we will add this hot water into the calorimeter or the cold water, it will give the final temperature of 9 degrees Celsius. So now, what we are looking for is the heat given off by the hot water, and using the formula Q for energy equals to mass times the specific heat capacity of water times the change in temperature. So the Q of hot water is 50 grams for the mass times the specific heat of water, which is 4.184 joules per grams degrees Celsius. And the change in temperature when we added the hot water, we have the initial of 40 degrees Celsius and the final temperature is 9 degrees Celsius. So final minus initial, we have 9 degrees minus 40 degrees Celsius. And if you notice that we have a negative in our temperature, and our Q here will be a negative sign. So let's say we will check the units. We will cancel the grams and the Celsius. What we left here is the joule as the unit of energy. Multiply all the values and we will arrive with 6,485.2 joules with a negative sign. And this negative sign here, it means that it is an exothermic reaction, since the hot water releases heat or energy and the cold water absorbs heat, showing the temperature rises from 5 degrees Celsius to 9 degrees Celsius. So our energy for hot water, an exothermic process, 6,485.2 joules. And that will be our final answer for this problem.